Lesson 17, Simpson's rule number 1. The diagram shows the first quadrant of the ellipse y equals square root of 1 minus x squared on 4. We have to complete the table for this. Now, if you've seen the previous video, you know what these values are, but if you haven't, just pause the video and substitute these values in. Right, now we'll just put those ones in. So it'd be, it's going to be 0.968, and this was equal to 0.866, and this was equal to 0.661. Now, in part 2, by using Simpson's rule with 5 function values, estimate the integral of the square root of 1 minus x squared on 4 between 2 and 0. Now, Simpson's rule requires 3 ordinate values. So again, I'll label these y values to make it easier. So the first one is y1, y2, y3, y4, and y5. Now this requires 2 applications of Simpson's rule, that one and that one. So it would be, and this is our h, so the formula for one application, area 1, would be equal to h over 3 outside of y1, the first one, plus 4 times the second one, plus the third one. Now, we can speed this process up by working at the second one, and then we'll work out a formula for it. So A2 would be h over 3 into, now this time we're starting here, that was y1, y2, that's y3, so it's y3 plus 4 times y4 plus the last one, y5. So the total area, we take the h on 3 out, and we'll have y1 plus 4 of these, 4 y2 plus y4 plus 2 of these, 2 y3s plus y5. Okay, now if you want to do more of these, the easy way to remember it, provided you kick this with a y1 to begin with. So this must start with y1. You say it's 4 times the even ordinates plus 2 times the odds. Now we just simply substitute these values in, and we get the area is equal to h. Now the h is like with the trap rule, it's 0.5, but it's a 3 under here, not a 2. The first one is a 1 plus 4 times, now this is your y2, 0.968 plus y4, which is 0.661 plus 2 times the y3, 0.866 plus the y5, which is 0. Now when you work all that out on your calculator, you get the result of 1.54133 as the approximation for the area underneath this curve. Alright, in part 3, given that the equation of the ellipse is x squared on a squared plus y squared on b squared equals 1, and the area of the ellipse is pi AB, find an approximate value of pi. Now, if you saw the previous video on the trapezoidal rule, we'll follow the same procedure. We'll get this ellipse in this form by squaring both sides, and we get y squared equals 1 minus x squared over 4. So x squared on 4 plus y squared equals 1. So a squared equals 4. which means a equals 2, b squared equals the 1, so b must equal 1. Okay, therefore, we know that the area here was 1.54133. That's the quarter of the ellipse. So to get the total ellipse, it will be 4 times that. So the area equals 4 times 1.54133. And that gave the total of 6.16533. Now, we know that the area is pi times AB, so we know that 2 pi is the exact area, but that must be equal to 6.16533. And when we divide by 2, both sides by 2, we get pi equals approximately 3.08. Now, which is a close approximation to pi. It's still not a very close approximation, but we only did 2 applications of Simpson's rule. With more applications, it's going to get closer. Remember that what Simpson's rule does, it uses a parabola to approximate this curve. This being an ellipse, which is a different conic to the parabola, you're going to get an error forming. Now, my other videos, we'll be looking at a different sort of function, and we'll get a much closer approximation to pi.